Now the main heart of this Fourier series. We would like to solve the example of the Fourier series. Fourier series of the function of any period. Let fx be a periodic function with period 2l in the interval c to c plus 2l. Then the Fourier series of fx is given by, remember this formula for solving the example. Fx is equal to a0 by 2 plus summation n is equal to 1 to infinity an cos n pi x upon l plus bn sin n pi x upon l. The coefficient of a0, an and bn, its formula is a0 is equal to 1 upon l integral c to c plus 2l fx dx. An is equal to 1 upon L integral c to c plus 2l fx cos n pi x upon L dx, and Bn is equal to 1 upon L integral c to c plus L fx sin n pi x upon L. Let us solve the example. Example: find the Fourier series expansion with period 2 pi of the function fx is equal to x in open interval 0 to 2 pi. Here the Fourier series with period 2 pi is given by. First I am writing here the formula. We have to remember this formula. Fx is equal to a0 by 2 plus summation n is equal to 1 to infinity an cos nx plus bn sin nx, where a0 is equal to 1 upon L. What is the value of L? Here 2L is equal to 2 pi. Our period is 2 pi. That means L is equal to pi. To substitute the value of L in our formula. That means a0 is equal to 1 upon L integral. Our interval is 0 to 2 pi. That means the limit of the integral is 0 to 2 pi. The given function is x dx. Putting the value of L, which is pi, the integration of x, we know it is x square by 2. The limit is 0 to 2 pi. Simplify. 1 upon pi, 2 is outside, 2 pi whole square, that means 4 pi square, equal to 2 pi. That means the coefficient a0 is equal to 2 pi. Another Fourier coefficient an we want to find. We know the formula of an is equal to 1 upon L integral. Our interval is 0 to 2 pi fx cos nx dx. The value of fx is x and the value of L is pi. 1 upon pi integral 0 to 2 pi x cos nx dx. Integral by parts. U means x and V means cos nx. We know the formula of integral by parts. First, x as it is, integration of cos nx, it is sin nx upon derivative n minus the derivative in previous term. The first term is x, its derivative is 1, and integration in previous term of the bracket, that means minus cos nx upon derivative n, and here there is n, that means n square, and limit is 0 to 2 pi. First, putting x is equal to 2 pi in whole bracket, that means 1 upon pi. Then sine, the value of x is 2 pi, that means sine 2n pi. We know that the sine 2n pi, what is its value? We have done in part 1 of the Fourier series. The first, I am writing the value of sine 2n pi. It is always 0. Also sine 0 is 0. Clear? Then cos 2n pi. Cos 2n pi, it is always 1, because here 2n pi, it is even number. Cos 0 is equal to 1 and sine 0 is equal to 0. Putting the value, that means equal to 1 upon pi, sine 2n pi, it is 0, minus minus plus, cos 2n pi, it is always 1. That is 1 upon n square. Minus times, putting x is equal to 0 in whole bracket. Sine 0 is 0, cos 0 is 1. Minus minus plus, again minus, that means 1 upon n square. Here plus minus cancel, its answer is 0. Okay? Now, we would like to find the value of Bn. Bn is equal to 1 upon L integration, its limit is 0 to 2 pi fx sine nx dx. Now, the formula of the Bn is 1 upon L integral 0 to 2 pi fx sine nx dx. Substitute the value of L, which is pi. Our interval is 0 to 2 pi. Therefore, limit of the integration is 0 to 2 pi. The value of fx is x and sine nx. Again, here we are using integral by parts. That means we take the value of u is x and value of v as sin x equal to 1 upon pi u as it is. Integration of sin nx is minus cos nx upon derivative n minus the derivative of x, which is 1, and integration of the bracket with sine. That means integration of cos is sin nx upon derivative n, and we already have n, that means n square. The limit is 0 to 2 pi. Now substitute the value x is equal to 2 pi in whole bracket. Cos 2n pi is 1, sin 2n pi is 0. That means minus 2 pi upon n into 1 because cos 2n pi is 1 minus sine 0 is 0, then minus minus plus cos 0 is 1 but x is 0, 0 into anything it is 0, sine 0 is 0. Pi pi cancel, that means minus 2 upon n. Now substitute the value of a0, an and bn in our Fourier series formula, which is fx is equal to a0 by 2 plus summation n is equal to 1 to infinity an cos nx plus bn sin nx. But an is 0. That means no need to write here an. The value of bn is minus 2 upon n. Sin nx. This is our answer. What is the value of a0? We already found the value of a0. It is 2 pi. So substitute this value here, 2 pi. 2 cancel, that means pi plus substitute the value of summation minus 2 outside. If n is equal to 1, that means sin 1x plus n is equal to 2, that means sin 2x upon 2 plus sin 3x upon 3 and so on. Clear? This is our Fourier series expansion of the function fx is equal to x. If you want to learn some more topics in mathematics, then please comment us. If you like this video, then like it, share it and subscribe it. Thank you.